In this section, we are going to piece together the material we have learned about so far in order to make a simple but real-world application. We are going to create a find and replace command line interface program to locate text in a file and then replace it with whatever we choose. So let's get right into it. The first thing we need to do is obviously just create a new project. So I went ahead and did that. I named mine CLI for command line interface, but feel free to name yours whatever you want. So the next thing we're going to do is add in a couple of dependencies into our cargo.toml file. And the first one is going to be called text colorizer. We'll set the version to 1. And then regex, and we'll also set the version to 1. So just to kind of show you what these dependencies are, text colorizer is just going to give us a couple of functions to enable and disable coloring. And this is just going to allow us to add some style to our output in the terminal. And then we have our regex crate, which is short for regular expression. And this crate's going to allow us to look for a certain expression in our file. And then we'll be able to change it based on some arguments that we're going to accept in. So this is a very important crate for what our program is going to do. So just to come back and look in here, we see we have regex equals to 1. And Cargo does this really cool thing where crates that have reached a 1.0 version in Rust, they begin to follow semantic versioning. This means that all version 1 changes should maintain compatibility with older versions. So version 1.2 will be compatible with 1.3 and so on. But once version 2.0 is released, then 2.0 is no longer required to be compatible with 1.0 versions. So another thing is, and if you saw this in the regex, we're at version 1.5.4 is the latest. But in here we have it only as version 1. So Cargo also does this thing where if we specify, hey, we just want 1 for the version, Cargo is going to automatically use the newest available version prior to version 2. So this one is essentially equivalent to version 1.5.4. So that's all we have to do in our cargo.toml file. So now we can start looking inside of main. And we can start thinking about our program structure. So our program is going to take 4 arguments: a string to search for, a string to replace it with, an input file, and an output file. So we can keep all these arguments together by grouping them into an arguments struct. And all of our fields are going to be strings. So we're going to have a pattern, which is what we're looking for. We're going to have replace, which is what we're going to substitute in for our pattern. And then we're going to have our input file and our output file. So to help us debug, we're actually going to add in an attribute called debug. So we're going to derive debug, and this is just going to allow us to use the standard output a little better to kind of format how we want to be able to print out our argument struct to be able to see the values associated with our field. So it's just going to help us kind of debug our struct. And now we see that we have a bunch of warnings already for having dead code. So I actually want to suppress these. That way when we output to the terminal, we don't get a ton of warnings outputted with it. I'd like to keep our output to the terminal pretty clean. And that's what allow dead code does. So now that we have our struct set up, let's just go ahead and bring in our text colorizer, and we'll just bring in everything that's within the crate, which is what that wildcard is going to do for us. It tells it to just, hey, make everything inside that crate available to us. So now we can create a new function, and we'll call it print help. And in here, we're going to use a different form of print line. And it's going to be the ePrintLine macro. And the ePrintLine is going to print to the standard air with the new line. So it is equivalent to printLine, except the output goes to standard air instead of standard out. We should only use ePrintLine for error and progress messages. Otherwise, you should continue to use printLine instead. So in here, let's just start adding in some messages to help the user understand how to use our program. So what is our program going to do? It's going to replace a string with a new string. And then our program, because we put in our curly brackets, it's going to be called find and replace. And then we want it to be green. So that's how we change the color in this case. And then we also want to print out how to use our program. So we'll say usage target string replacement string input file, and then we'll have output file. And that's all we need to do. So let's come up here, let's call our function, and now let's come down here and run it, and it's going to build our dependencies for us. And now we see that we have find and replace in our green text that we specified, replace a string with the new string, and then we see that it has usage, target string, replacement string, input file, and output file. So everything looks good, and everything was printed out the way it should be. So in the next lecture, let's look at how we can take in user arguments from the command line. So now let's look at how we can accept and use command line arguments. The first thing we need to do is bring standard envir into our scope. So inside of main, let's now create a vector called args. So let args, and then we know it's going to be a vector of string. And we can say environment, that's what it's short for, args, and then in skip1, and I'll explain that in a second, and then we have a collect iterator for us. So we're going to use skip1 because when we run our program, that is actually the first argument. But we don't want that one. We want everything that follows our program name. And that's going to give us the rest of everything else. So we also know that we want 4 arguments. We don't want any less, and we also don't want any more. So we want our length basically to equal 4. So if it does not equal 4, then we want to print our help out for us. So now we can remove this, and now we can also say print line, and we want to provide them a useful error message, wrong number of arguments given, expected for, got, and then another value passed in. So we'll say error, and then we want it to be red, and we also want it to be bold. And then we want to look at how many arguments we actually were printed out. And then if we get to this point, we don't want our process to continue, so we want it to actually exit, and then we want it to exit with error code 1, which signifies that our program did not run successfully. So now let's do a couple of runs. So we'll say cargo run, and let's see what it does. So we see we have find and replace. So, good. So that was our print help function being called. And then we see error, wrong number of arguments given, expected 4, got 0. And now we see also error, process didn't exit successfully, which is right here. So great. So we see that it was running correctly. So now let's try running it and give it 4 arguments. So we'll say arg1, arg2, arg3, and arg4. And everything ran correctly. So obviously we don't have the logic in yet to handle our arguments, but this is a great start to our program. And now we know how we can utilize accepting arguments in from the command line and making sure that they are being stored correctly inside of our args vector. So now let's look at how we can actually structure our program correctly and separate all of this logic into different files. That way we only use main to run our program and not handle all of our core logic. So again, we could very easily keep everything in main.rs because this will be a small program. But let's take a quick minute to implement good practice and place our code in another file, and then we will just have main call that code. So let's create a new file inside of source called find and replace. And in here is where we can store all of our logic. So let's take all of this, cut it out of here, paste it in here, and then let's take this function, cut it out of here, and also put it in here. And then we're going to create a public function called run, which is where we can take all of our logic inside of main, take it out, and place it inside of here. So now we can come into main.rs and say mod find and replace. And now we can just say find and replace run. And it's able to find it because run is public. So all of that is good. But now let's just make sure before we try running this, let's look at our tree. So remember, we can use cargo modules, generate tree, and then I want to generate mine with types. That way I can see everything. Okay, so we see we have our find and replace module. We have our struct in here, private, great. Our print help function is private, perfect. And now our run function is public, which we then call inside of main. So everything looks good. So now let's run it, make sure our error messages is printed out. And they are. So now let's run it again with giving it 4 arguments. And perfect. So we're back at the same place we were prior to separating our code into a module. So now we're right back to where we were, and now we can continue on with handling our file logic. Okay, so we're receiving our args here, and we're placing them inside a vector string. So let's create a new function called parse args. And inside here, we want to return some arguments. So let's actually take this logic out of run, place it inside of here, and now in here we'll just call parse args. And now that we're looking to return a argument struct, what we'll do is we'll create it, and we'll say our pattern is going to be args of 0, and then we just want to clone it. That way we get a copy of it, and then we want to do the same thing for the rest of our fields. So we'll have input file, is going to be args of 2. And lastly, our output file is going to be args3.clone. Okay, so now we're getting all of this printed out. So let's actually just make sure that what we get is correct. So let's print out our args right here. There we go. There. And now we'll say args. So if we run this, helps if I add in arg1, 2, 3, and 4. We see that our pattern was assigned arg1, replace arg2, input arg3, output arg4. So everything there looks correct. So we know that we're handling and assigning our arguments into the arguments array properly. So now we'll actually keep it that way. So we'll say let args equals parse args. So now we need to handle how we get the data to and from the file system. So we have done a little bit of this before, so we already know that the designers of the standard library made this pretty easy for us to do. We do need to import in the standard file system, and this is going to let us gain access to the methods that we require. So now we can create a read and write function which is going to accept a reference to our arguments struct that we just created, and we're not going to return anything, but now we're going to say let data match and then the fs, which is file system, read to string, and we see that it's going to return a result to us, but we need a path to what file we want to read in, and it's going to be our args input file. So now that we know that we also returned in, or we're getting returned a result, we need to make sure we handle the errors in case that we get any. So if we're returned an OK, awesome. We want that the result inside of the OK to be assigned to data. Otherwise, if we get an error, then we need to handle the error. So we're going to print out failed to read from file, and then we'll print out our file name. And now we're also going to want to print out our error for us. So we'll do again what we did earlier, err.read.bold, and then we want to print out our args.input file name, and then we also want to print out the error. And as we did earlier, we want to make sure that we exit the process with an error code with an exit code of 1 to signify that, hey, it was not a successful completion. And then we also want to match on writing, because we are eventually going to have to replace the strings in our file with our desired replacement string. So in here, we're going to have our args.output file, and then we're also going to need the data, which in this case, what we're going to do is, just to get this logic wired up, we're just going to basically copy the cargo.toml file and then just output it to a copy.toml file, just to make sure that our reading and writing logic is being done correctly. So in this case, we do not care what the OK result is going to return, but we do care if we get an error. And I need to correct that. And again, like what we did earlier, instead of it being reading, it's going to be writing, failed to write to file, error, and then we'll have output file, and then we'll also have our error message there. Awesome. So all of that should be good. We'll call read and write, and then we'll pass in a reference to our arguments. So just to make sure our error logic still works, we call cargo run with no arguments. We see that our error messages are printed out successfully. So now in this case, we will say cargo run arg1, arg2, because we don't necessarily care about those yet, because that'll be what our regex is looking at. And now we want to do cargo.toml to copy.toml. Okay, so it ran successfully, and we see that we were generated a copy.toml file. So if we look at our cargo, that's what we see, and then inside of here we see that they are the exact same thing. So with this, we were able to verify that our reading and writing to file logic is being done correctly. So now the next step is going to be to find some strings in a text and then replace it with a new desired string, which we will do in the next lecture. In this lecture, we will begin using the regex crate we put in our dependencies earlier on. So let's start out by just simply importing it in. And now we want to create a new function called replace, and it's going to accept 3 parameters. Our first one is going to be our target, which is going to be a reference to a string slice. And our target is going to be the pattern that we want to replace. And then we're going to have our replace, which is also a string slice, and that's going to be what we replace our target with. And then we have our data, which is also a reference to a string slice. And our data is going to reference the input, the text we read in from our input file. So now we're going to return a result, and in the event that the result is okay, we want to return it with a string. Otherwise, if it's an error, we want to return a regex error. So now we're going to call regex new. So we'll say let regex equals regex new, and it's going to be done on our target, which is the string that we want to look for. And this method can fail. So in the event that it does fail, we want to propagate it up, which we learned earlier on in this course that is done by adding a question mark at the end. So assuming that the method successfully runs, then we want to return OK, and then we want to say regex dot replace all, and then we want to replace all of the targeted strings inside of data with the string that we want it to be replaced with. And then we want to just say toString, because that is how our result expects it to be returned. So we are making sure it is explicitly going to be returned as a string. And that's all we have to do inside of that function. So now we need to add this into our core logic. So we're going to say let replace data, and then we're going to match on replace, and our target is our args.pattern. Our replacement string is args.replace, and then our data is just a reference to the data we created right here. And then inside of here, I need to make this as a reference. And then inside of here, if it is okay, then we want that data to be given to us and assigned to replace data. And then otherwise, if it's an error, well, then we're going to just kind of follow what we have been doing. So our first thing is going to be the red and bold error word. And then we're going to say fail to replace text. And then we want our error message to be printed out. So now we're going to say error.red bold, and now our error message. And then we want our process to exit with error code 1. And now for writing to the new file, we want to write in our replaced data. And that should be all we have to do. So now let's test this out. So we're going to create a new file called test.txt, and then inside of here we will say this is a test. We'll save it, and now we can run our program, say cargo run, and we will say this is a test, and that's what we want to replace, and we want to replace it with success. And then our input file is test.txt, and then test modified.txt will be our output file. So now let's run it, and it says wrong number of arguments given. Oh, I need to put these inside of quotations. There we go. So now let's check our test.mod, our test mod, and we expect it to just say success. And inside, that is exactly what it says. So we have successfully found and replaced strings. But let's make sure that our error handling is correct as well. So we'll look for an open and closed bracket, and we'll just say inside of, we'll replace it with test, and then we'll say test.txt, and we'll say error.txt. So I know that this should fail, but let's make sure that it does. And it does. So we see that we have a regex parse error, unenclosed character class. And it failed right here. So we see that our error was propagated up. So now we have successfully handled our errors and created a find and replace command line program. So we have successfully put together a lot of the main points we have learned about so far in this course. So congratulations on the achievement of making it this far and understanding the logic behind what we have been doing. So let's continue our Rust journey in the next section.